Hey everyone, my name's Nat and welcome back. In this video we will have an extensive look at an advanced and customizable leveling system which we can add on to our health bar from the last video in the series. Now while it isn't essential to have seen the last video, it may help with some parts of this video, so if you're finding it hard to follow along, feel free to go back and check that one out. In saying that, I have tried to design this in a bit of a standalone way so it can be applied to your existing systems as well. The whole project can be downloaded from the link in the description, and there are a few scenes which demonstrate what we can do with this system. First, we'll need to do some more setup of the UI elements, and this process is going to be very similar to the health bar tutorial, but we're going to be taking a different approach to how we use it. So to keep our project organized, we'll create two new game objects, and we'll parent them under our player UI. We'll name the first one health bar, and we'll name the second one XP bar. We'll take our three health bar images and parent them under the health bar game object, duplicate the front and the back health bar, and we'll parent them under our XP bar game object. Rename the back health bar to back XP bar, and the front health bar to front XP bar. We want to make sure that the frame is the last child of this game object so that it renders above all of our other images. So now we can grab our two XP bar images and drag them into the lower part of the frame here. We'll scale them to fit. And we'll pop in our front XP bar image. Now we can head over into our scripts folder and create a new C# script. We'll call this level system. And we'll open this up in the code editor. We'll set up our variables at the top of the script. We'll need a public int for our level, a public float for our current XP, another public float for our required XP. We'll need two private floats, one for the lerp timer. And because we're going to add a delay before our XP bar starts filling in, we'll also need a delay timer. We want to make sure that we're using unityengine.ui at the top of the script. And we want to create two public images that we can drag our XP bars into. Before that, I'm going to add in a header with UI in the brackets. And now we can have our two public images, one for the front XP bar and one for the back XP bar. So down in the start function, we want to have front XP bar dot fill amount is equal to current XP divided by required XP. And we'll do the same for the back XP bar. At the start of the game, the current XP will be 0, and this is just going to empty both of our XP bars. Now this part will look quite similar to the health bar video. We'll head down to the bottom of the script and we'll create a new function, which is going to be void, and we'll call it update XP UI. In here, we'll need a local variable to store the decimal fraction of our XP. So type in float XP fraction is equal to current XP divided by required XP. And we'll also need to store the fill amount for the front XP bar. So we'll call this one FXP. And this will just be the front XP bar dot fill amount. And now we need to check if FXP is less than XP fraction. So this means we have gained experience and we need to update our UI. So if FXP is less than XP fraction, we have gained experience. Then we can start incrementing our delay timer. And we want to immediately set the back XP bar dot fill amount to equal XP fraction. Then once our delay timer has reached a certain number, I'm going to use 3 in here. You can make this a public value if you want to change it. Then we can increment our lerp timer. And then we want to store a local variable for %complete. And instead of using the chip speed like in the last video, I'm just going to hard code in 4. So that the animation takes around 4 seconds to complete. And then we can do our lerp. So we can type out front XP bar dot fill amount is equal to mathf.lerp. And we are lerping from the FXP value until the back XP bar dot fill amount value. And we will lerp by %complete. And that's all we need to do to update the UI. Now we can create a function to gain experience. So we'll head down to the bottom of the class and we'll create a new void function, call it gain experience flat rate. And this will take in a float for a parameter called XP gained. And this is going to be pretty simple. All we need to do is set the current XP plus equal to XP gained. And we want to reset both of our timers. Now we'll head back into update and we'll call the update XP UI. Under that, we'll do a simple input check for get key down. And I'm going to use keycode.equals because it's the plus key. And then we can just call gain experience flat rate and we'll pass in 20. Now we'll head back over into Unity, select our player object and drag our script on there. We'll set the level to 1 and the required XP to 130. We'll drag in the back XP bar and the front XP bar. And just before we test, I'm going to go to the back XP bar and change its color to green. And we'll hit play and test. So now if I hit the equals key, you can see that the back XP bar fills in for 3 seconds and then the front XP bar lerps to match it. So now we have a very basic way for our players to gain experience, which we'll do for the moment. Now we want to create the logic to actually level up. So we'll head back into our script and we'll create a new function called level up. We'll head back into update and we'll check to see when we need to level up. So if our current XP is greater than our required XP, then we want to level up. And the first thing we want to do when we level up is, yep, you guessed it, increase our level. So we'll type in level plus plus. We'll want to empty the fill amount for both the front and the back XP bars. So front XP bar dot fill amount is equal to 0 and back XP bar is equal to 0. And we also want to take the remaining XP that we had before leveling up and carry that over. We can do this by setting current XP is equal to mathf.round to int. And then we can pass in current XP minus required XP. And finally, if we want to gain any skill points or alter our player's attributes, we can do that here. For this video, I'm just going to increase the player's health. So we'll create that on the player health script and we'll call that function here. And the player health script lives on the same game object that this is on. So we can just type in get component player health, and then we'll call the increase health function, which doesn't exist yet, but we'll create it on the player health script. And for this, I'm going to pass in the player's level, head over to our player health script, and all the way down the bottom, we'll create a new public void called increase health. Takes a int as a parameter for the level. And in here we can just set the max health plus equal to health times 0.01f. And we'll pop this in brackets. And then we'll multiply that by 100 minus our level. And then we'll multiply that by 0.1. Then we want to refill our health bar, so we can just type in health is equal to max health. Save both of our scripts. Head back over into Unity. So if we hit play and test it out, we'll gain enough experience to level up. And you can see that after we've leveled up, our level has increased, our health has increased, and we've carried over any extra XP that we gained before leveling up. We'll jump back into our level system, and before I continue, I just want to say I did a lot of prototyping to write up my own algorithm to calculate the required XP for the next level. And while what I did was somewhat functional, I couldn't quite get it to work how I expected. So after doing some research, I've decided that for this video, we're going to modify and adapt the algorithm found on the Runescape Wikipedia. There is a link for that in the description. I've discovered this method in Coding with Unity's video on YouTube. They do a great job breaking down the algorithm, showing it step by step. So if you're struggling with implementing this part here, go and check out their video and it may help clear up a few things. There is a link in the description for that as well. So we'll create a new private function which returns an int and we'll call this calculate required XP. In here we want to create an int and we'll call this solve for required XP. And this is going to be set to 0. And then we want to loop for as many times as we have leveled up. So for int level cycle is equal to 1 until level cycle is less than or equal to level. Then we will increment level cycle. Inside the loop is where we will implement the algorithm. And what we are doing is we are taking our level minus 1 plus 300, and then we are taking our level minus 1 divided by 7, powering it by 2, and then multiplying these values together. It sounds confusing when I say it like this, but once we start implementing it will all make sense. So if we look at the algorithm, you will see there are 3 arbitrary numbers. There's 300, 2, and 7. These are numbers that we can change and even make public in our code. So we'll go up to the top of the script and make floats for each of these values. The first one we'll call addition multiplier. We'll set this to equal 300, which is the plus 300 here. The second one we will call power multiplier, and that is the value 2 here. And the third one we'll call division multiplier, and that is the value 7. And I'm going to add a range header for each of these. I'll also duplicate the header, put in the word multipliers here. Now back down in calculate required XP. What we want to type is solve for required XP is plus equal to mathf.floor, which will always return the lower integer of a floating point value. So if we have a 4.9, it will still return 4. And in here we'll use level cycle plus addition multiplier, and then we'll times that by mathf.pow, and we are powering it by power multiplier, and the value we are powering is level cycle divided by division multiplier. And this is coming up as an error because we are trying to pass a float into an integer variable. So we'll just cast this as an int. And the last step in the algorithm is dividing it by 4. So outside of the loop, we can just return solve for required XP divided by 4. Now head up to our level up function, and all we need to do is set our required XP to equal calculate required XP. And because this will only run in our level up function, we also want to take a copy of this and pop it up in start. So we'll save that, we'll head back into Unity, and we'll test it out. So with the default values in the algorithm, our level 1 required XP is 83, and if we hit the equals key until we level up, level 2 is 174, level 3 is 276, and so on. Now keep in mind that the required XP that we're getting here might not work for your game, and that's why we made all of these multipliers public. You can adjust these values to make a system that better suits your game, but it can be hard to figure out exactly what values you need. So if we save our scene, and let's head over to the first demo scene, which is called XP Visualizer, we'll hit play, and it populates a bar chart where the player's level runs along the x-axis and the required XP runs on the y-axis. You can change the sliders here to update the bar chart and reflect the new values. The second and the third multipliers will adjust the severity of the curve, and the first multiplier will adjust all of the values equally and will have a minimal effect on the curve. So use this scene to figure out exactly what values you want to put into your system. Now I want to take a moment here to talk about how we might want players to gain experience. What tasks or actions in your game will net the player experience, and how much experience does the player gain? These decisions will affect other systems in the game and the strategies players will employ. So before you get too far into setting up a system, it's really important to plan and prototype to figure out how your systems will interact with each other. Most often, games will have players killing enemies and completing quests to gain experience. In some cases, enemies will have a level as well, and quests will have a recommended level. There are a lot of variations on a level up system, and every design choice will change how you implement what we cover in this video. With this in mind, we can make a system that has a base reward and scales for every level that the player has surpassed the enemy or quest. So we'll head back into the level system script and we'll create a new public void function called gain experience scalable. This function will take in two parameters. The first one will be a float for XP gained, and the second one will be a int for the past level. And this will be the level of the enemy or quest. So in this function, we're going to check if the past level is less than the player's level. Then we'll want to scale our XP gained. So we can type float multiplier is equal to 1 plus level minus past level. And then we'll multiply this by 0.1. Then we can set our current XP plus equal to XP gained times multiplier. Otherwise, if we just want to do current XP is plus equal to XP gained, which is our base value of experience. We also want to reset our timers in here. So you can just use either one of these functions. You don't have to use both. I've just added them both here so that we can go through and explore the different options available to us. I will demonstrate this function, gain experience scalable, in the next demo scene, but for now I'm just going to speed through the setup of a few text meshes, and then we can go into the coding to set those up. So there is a text for our player's health and two texts for the player level and XP. We'll start off in our player health script, and we'll make sure that we're using TM Pro at the top to allow us to use the text mesh plugin. And if you don't have the text mesh package imported, then you can just use the standard Unity text. We'll create a new public text mesh pro UGUI, call it health text. And at the bottom of the update health UI function, we can just type health text.text is equal to mathf.round. We'll round the health value plus / in quotations, and then we'll plus mathf.round max health. Save that, head over into our level system. Make sure we're using TM Pro at the top here. And under our UI header, we'll create two new text meshes. Call one level text and the other XP text. In start, we'll type level text.text is equal to level space plus level. We want to make sure that we do this in level up as well. And in the update XP UI, we can type XP text.text is equal to current XP plus / plus required XP. And that's all the coding we have to do for this video. We'll set up the rest of the UI, test it out, and then we'll have a look at the next demo scene. So we've got 100 out of 100 health, we're level 1, and we have 83 XP to gain. So if we level up, we have 110 health, 120, 132. 512 XP to gain. 145 health. And so on. We'll save our scene. So that's all the difficult part of this video. Now let's check out the next demo scene. And this is a simple space shooter which will show the implementation of the system. I won't go into the extra scripts I've written for this scene, but you can download them and pick them apart to make it work with your game. So in this scene you can boost forward by pressing W, you can fire by clicking, and it's got all of the systems that we've created over the last two videos in action. Notice that the level 1 spaceship here is going to give us 7 XP, and this level 2 spaceship will give us 14. Let me speed through the footage a little bit until we are a higher level. Now we have a level 2 spaceship that is going to give us 18, and a level 1 that will give us 10. And this is the gain experience scalable function at work. So I hope you enjoyed this video and learned something. If you enjoyed watching, please like and subscribe, and if you have any comments, questions or suggestions, then I would love to hear from you. For the next video in the series, I will expand the space shooter here and we'll look at gaining and spending skill points to alter different attributes of our player. Thank you so much for watching, and I'll see you in the next video.